So topic today we are going to cover human space flight mission. What are the challenges and what way it is opportunity to all section of society. Uh, it is vast and its vastness humbles humanity. We are just even we are not even visible as a dot on this particular screen as Earth as a whole. So this is a challenge to us for exploring the universe, know more about it, and there could be various kind of exploration, and one of the exploration is human exploration. So that is where the seed of human space flight is laid. So let us discuss why at all such a thing is required. So there are various contexts, and I will try to bring out one of the contexts which really is linked with uh, the survival of Earth and the need of human species to find another home. So all these things are, if you look at this, the life at all Earth is tightly linked with the sun. So just a minute. So we know a little bit about sun, that is we are always taught that this is nearest planet, and Earth moves around it, and we are all worshipping it as it is a source of energy, hence life. The question comes whether this source of energy will be there forever. And all of you know the answer is no. As nuclear fuel at sun gets exhausted, it will we have to look at the processes, what is going to happen beyond that. So the solar revolution, uh, this is it is ultimately decide the Earth's fate. And if you look at the this particular diagram, uh, we as a Earth and Mars, we are at the right distance from the sun, and we receive the right amount of energy, and neither too hot nor too cold. The water can stay at the liquid stage, and that is what is considered as a ideal condition for the our kind of life. So the our sun is just a 5 billion year old aging star, and maybe another 4 and 5 billion years this is going to exhaust our nuclear fuel, and then it will become a red giant, and the habitation zone will simply shift towards Jupiter and beyond, and that is where the life at Earth will not be feasible. So this is one of the reasons that we should build the technologies, we should build the processes to go leave the Earth and somehow find another home on some other planet, and whole world is working towards that. I'm not telling that this is the only reason, but this is one of the reason to this is required for the survival of humanities. And now let us discuss what is a space, and then only you will appreciate what are the challenges of the human space flight mission. So the space is defined as a something around 100 kilometer above the Earth's surface. What are the things there? Let me just tell. It's deep vacuum, no air. Apparently, you don't feel gravity. Extreme temperatures, they can swing to plus minus 250 degrees centigrade, depending on whether you are exposed to sun or you are not exposed to sun. The same body can have one side minus 250 and other side 100 or 200 degrees centigrade temperature. Then radiation. So charged particle, which are not good for the health of human being. Lot of debris. Some of them are man-made. Some of them are naturally trapped from the uh, cosmic particles or debris from the asteroids and so on. So the Earth space is a very unforgiving place, and the surviving in this environment itself is a great challenge. So if you have to stay alive and flourish, the technology development has to be there to address these difficulties, and this is going to be a very long process. So that is why the work has to start now. If we talk about the journey to space, there are three categories. One is near to our home planet. We call it LEO, human space flight. Then next stop is Moon, which is the test bed for the testing all the technologies with, with a reasonable cost. And third stop, which is considered as a ultimate stop, is which will prove all the technologies, is Mars. So the many technologies are being tested in the low Earth orbit, and then we are going to migrate towards Moon, and then towards Mars. This is the global roadmap whole space community is currently working towards maturing these three steps. Now, if I summarize if you go to the space, what are the challenges? It is called as a RIDGE, RIDGE. So the radiation that primarily comes from the solar flares from the sun. And actually, we are very lucky to have atmosphere and magnetic field around us. They are the great protective shields, and they take care of most of the harmful radiation and most of the harmful particle or meteoroids which can harm us. So everything is getting burned in the Earth's atmosphere, and magnetic field is not allowing the charged particle really to reach us. So as you go away from the Earth, these two shields are broken. So radiation becomes one of the problem. Then when you are going, right now the technology is not uh, good enough to take large number of humans. The capsules in which you have to travel is really tiny, really cramped. So the isolation from the rest of the world is one of the problem. It is like putting you into a cell of the jail with no visibility of what we see every day. We are used to see the nature, which will not be visible from there. Then the distance from Earth itself becomes a challenge in the managing the human mission. So as you go away, you need connectivity to Earth for the control and many other purposes. So the distance from Earth is one of the technology challenge. Now the gravity. We evolved on the surface of Earth over, uh, I mean, billions of years. The In the presence of gravity, we have adapted ourselves. All your body, everything, all the systems are designed to work properly in gravity. The moment the gravity is reduced, there are several effects which I will discuss in the next slide. And then hostile environment, I already explained in the earlier slide. So all these things needs to be addressed, and they are the challenge of the human space flight. So let us look at the stressor. Uh, so ultimately, we have to protect ourselves and survive in a space. So the first of the problem is the vestibular system, which is designed to again work on the gravity and sense of orientation, etc. That goes away, and this needs this leads to motion sickness, nausea, vomiting, and that is why this is called s- space sickness. So uh, first problem happens like this. Then the eyes. So there is a fluid motion happening because of the see when you are standing on Earth, uh, your whole body fluids are adjusted in such a way that they are properly distributed. The moment gravity is removed, there will be fluid movement towards upper body, and that leads to the several issues. Uh, Now, visual system also compromised. The respiratory system also will have a different functioning. Uh, Nervous system damage happens. The muscle atrophy happens, and the muscle starts degenerating. Bones starts degenerating, and uh, the moment you are away from the Earth, your radiation shield is gone. Then the our body, it is like exposing to multiple X-ray every day if you are not protected properly in this. To the genetic mutation, cancer, immune system also is compromised. The cell repair does not happen the way it happens on the Earth. Our the heart, which is a pump, which also is designed to work in gravity, will start functioning differently. So that your blood circulation will get affected. Then your circadian clock, like we are used to about 12-hour light and 12-hour dark, and our sleep patterns are adapted to that. In the space, there is no sunrise and sunset will not happen as it happens on Earth. If you are in the low Earth orbit, every 90 minutes you are going to see a sunset and sunrise. One orbit you are going to make in 90 minutes. So due to all these disturbances, uh, the human body survival in a space for the long duration is a challenge, and the full understanding of such effects cannot be there unless you keep on doing the low Earth orbit space flight, the space flight to moon, and so on. But despite of these risks, there are several benefits uh, which is even important for the species which will survive on Earth. So it is not like that the all the technologies which are being developed for space is only used for space flight. No, there have been great examples where the technologies which were developed for the human space flight is really helping to improve life on Earth. So if you look at the various domain, let us say science, so it helps in the medicine, material science, engineering, robotics, energy system. Then it also it is also one of the economic activity where the whole ecosystem is there to develop the technology for space flight, build the rockets, build the capsule, manage the human space flight. So all these things are uh, one of economic activity also. And then of course uh, space is always like fascinating for the youngsters who are just in the school, and that inspires the generation to take the STEM fields and contribute to the space. Now I'll just quote few examples where the spin-offs of the human space flight technologies really helped. So, sunglass, to my surprise itself, is the outcome of the space flight, where the eyes were to be protected from the ultraviolet rays, which are uh, at very dangerous level when you just cross our atmosphere. Computer mouse, then the MRI, smoke detector, quartz watch, because mechanical watch will not work there, barcode. So more than 30,000 spin-offs, not only human space flight, if you talk about the space flight altogether, is part of that. Uh, then space shuttle fuel pump technology actually has been converted into the heart pump, and the moon boot, the boot which was required for the flight moon landing by the astronaut, actually the seed of the our sports shoes, because that is where the shock absorbing capability was required, and the superior stability and motion control was required. So the sports shoes are actually the adoption of the moon boot. So there are many such technologies like packed food that was required for the space travel. So there have already been so many spin-offs, and it is expected that as the space technology develops, there will be more spin-offs and more impactful. It will be very impactful for the life on Earth too. So just one aspect I want to bring here, that the space we want to do the human space flight with a very limited resources. So so the recycling of the resources is one of the very important aspect of human space flight, and that recycling can really help the, to develop the technologies which can be in fact adapted on Earth, which can work with the very low power, very low water requirements. So there is a huge potential. The evolution of technology for human space flight will make us more energy efficient on Earth. So let us talk about our program, Indian program. So the human space flight program of India, we in ISRO we have been doing the precursor technologies for quite a long time, and the first of this was tested as a space recovery experiment, where we inserted a capsule of around 800 kg, and it orbited Earth for about 2 weeks and re-entered successfully and recovered. That is called space capsule recovery experiment. This was done in 2004. Following that, we tested the atmospheric re-entry of the crew module. It was a one. It was injected from 125 kilometer, and the technology from 125 kilometer to touchdown was tested. That is called crew module atmospheric re-entry experiment. Then uh, the we also tested the crew escape system. I will explain what is that in the few slides later. So uh, and we have been developing the launch vehicle, which is capable of lifting the crew along with the crew module, a heavy lift rocket, which is our Mark III. So once all these things started maturing, uh, the government got convinced that no, this is time to embark on a full-fledged human spaceflight program, and that is where in 2018 the Honorable Prime Minister declared the program, and the program is to currently develop the technology to launch our fellow Indians from our soil, take it to 400 kilometers, uh, and orbit around Earth for a few days, and then come back and splash down a predetermined location. So this is the main objective of the Gaganyaan program. Beyond Gaganyaan, we have some more programs. Under India Vision 2047, there is a roadmap of evolving from Gaganyaan to having our own space station, then having a crewed landing and return from the moon in 2040. So we are starting from the low Earth orbit transport technology. Then we are migrating towards the migrating from the short duration human space flight, which is called LEO, that is Gaganyaan, to a long duration human space flight, sustained presence in the orbit, and finally uh, setting the Indian foot on the moon. This is very, very challenging, but I'm sure that with all of you, your training to the next generation of students, these things are viable. Now let us look at the different aspects of the human spaceflight mission. So if you look at this particular chart, you need a safe access to space, which will be given by a specific type of launcher. So we need a very, very robust launcher. Then when you are able to launch there, then you have to maintain the Earth-like habitat for crew. That is called orbital module. So that is a capsule, the right side. So this is the second big technology element. Then when you are in orbit, uh, you have to find the solutions to combat the habitation challenges in space, which I talked about, that ridge. And after your mission is duration is over in the orbit, the descent and re-entry aspect, where you need a different kind of thermal protection system for the safe return. You need a de-acceleration system which can convert the very high velocity of 7 kilometer per second to kind of 7 meter per second at the touchdown. So that is the kind of scale of the de-acceleration. Then landing and recovery. So the splashdown is our splashdown is going to be in the ocean. So the timely recovery of the crew which comes back from the space is also one of the uh, challenge, because the different kind of sea states uh, can pose a potentially very serious hazard to the crew, which has already it is already weakened up due to the effect of the space flight, and not able to come out on their own from such capsules. Generally, assisted in egress is the thing. Now, just if we zoom further in these technologies, so the Gaganyaan, we have a human-rated launch vehicle, which is different from the normal satellite launcher, because we have to launch the capsule, which is their orbital module in the left side. This is the payload for this launcher, but we are attaching one more element which is on the top, which is called crew escape system. So the important aspect of human space flight is uh, safety of crew is the core requirement of the design. So other than performance of the engineering system, the safety, the design of engineering system has to be done in such a way that crew is safe in all kind of scenarios. So once you are launching a capsule where the human is sitting inside, so there are several aspects where you have to make that he is safe, he or she is safe. So let us say some malfunctions happens in the lower stage of rocket. They should have a provision to escape. So this is a small, a very powerful rocket which can lift the 8 to 9 ton of crew capsule and push it away from the ascending launcher. Even at the launch pad, if there is some emergency happens, the crew will not be able to come out immediately because they are suited up and everything is closed. There is no access to the in egress system. So at that time also launchpad emergency also there should be a provision to escape. So this particular crew escape system is a system which pulls out the only crew module and takes it away. So in case of any emergency they are safe. So the difference between the normal program and Gaganyaan normal space program where we build the satellites for different application versus Gaganyaan is the added feature for the saving the crew. So this particular crew escape system is the safety till you reach the orbit, and beyond that the crew module and service module they are designed to take care. So just the comparison, the normal one will have a launch fairing which is of the uh, this kind of shape, and the crewed vehicle will have the uh, launch escape system also attached to it. Uh, okay, if you look at the SpaceX Crew Dragon, which is currently chosen for the Subhanshu Shukla's flight, you don't see such kind of small rocket on the top of rocket. So the Crew Dragon, the capsule itself is designed with some kind of thrusters built in, and that is able to take the module away from the vehicle. So there are very different implementation of the crew escape system technologies. So USA, these capsules have adopted different concept. We have adopted slightly different concept. So if you look at the nominal launch sequence, so there will be a ascent phase where the whole vehicle is lifting off from the Sriharikota. Then there are two solid boosters which will get separated, and it will continue its ascent. And then after about 50 to 60 kilometer in the flight, this crew escape system, when you are about to make to the orbit, the crew escape system is no more useful. So this has to be ejected. Then the ascent will continue, and finally stage separations will happen, and then upper stage will, which is a cryogenic engine, that will inject the module in about 170 to 400 kilometer elliptical orbit, and beyond that the orbital module, which is actually if you look at the back side, it is a kind of satellite which we call it service module. I will show it in the next chart. That propulsion system will take it to its intended orbit. So if you just look at the orbital module separately, so the these two things are attached together and launched, so they go together in the orbit. The purpose of this is to provide the habitable space, and to provide the habitable space, there has to be oxygen, earth-like atmosphere, nitrogen and oxygen mixed atmosphere inside, with no hazardous gases building up there, and providing the human to have the life support system, um, avionics, de-acceleration system. So this particular crew module, which is astronaut when they are in the orbit, and also is a ferry to take them to space, and also uh, their safety when they are coming back. The service module, which is below, is actually a kind of system which assists this module. So it has the propulsion system. It is like you can see the rocket thrusters below, and power, maintaining the temperature, uh, then deployment mechanisms, and so many other technologies. So one of the important function of the service module is when the rocket injects it into the lower orbit, take it to the right orbit, then maintain its orientation, generate enough power, and once the orbital mission is over, provide a de-boost thrust so that the module is put on a trajectory so that it can land on Earth. So uh, this is the function of service module. So together, or service module and crew module is called orbital module. Now it is important to understand the mission profile of a typical Gaganyaan mission. So the ascent, I have already explained that it is injected into the 400-kilometer orbit, uh, finally reach to 400-kilometer orbit. But this I will always call the launch is always a easier path. Only care is taken with respect to the normal launch trajectory. The launch loads, which is like high acceleration which comes on the human body, the whole trajectory is designed to control that within the human tolerance level. So this is the only difference between the normal rocket liftoff versus a rocket with the human in. So that trajectory difference is the only difference. But when your orbital mission is over, the most difficult part is to make sure that it safely returns. So now, for the safe return, you should have the very powerful propulsion system. So generally, you are moving like this. Your crew module is ahead, and the service module is on the um, back side. But when you want to come back, the whole thing is flipped 180-degree. The thrusters are fired to a duration that this trajectory is now no more orbital trace. It becomes a kind of a trace which falls towards the Earth. So now everything becomes like falling from free fall from 400 kilometer. So even if there is a free fall from the 100-meter, it is fatal. Now we are falling from 400 kilometer at the velocity close to 7 kilometer per second. So probably maybe 30,000 kilometer plus per hour. So that is the kind of velocity through which you are. Then I was talking about the we are lucky to have atmosphere on Earth. So the atmosphere helps us to retard the and absorb the lot of most of the kinetic energy which was imparted by the launch vehicle to the crew module, and the re-entry starts. Now, as there is a high velocity, you are entering into the atmosphere, the crew module gets heated up because of the friction, and the surface temperatures could be very high. It can go between 2000 to 3000 degrees centigrade. So you need the different kind of thermal protection materials which can survive these things. And the space shuttle Challenger disintegration was only because one of these tile was broken. So, so this is a very important technology. Now, as you come closer to Earth, uh, you cannot just your velocity is less, but it's still not uh, slow enough to control the jerk, which will be a fatal. If you touch down, it will be a fatal jerk. So what we do, we use the parachute. So for most of the retardation happened because of the presence of atmospheres, the atmospheric drag. But in the terminal phase of the mission, the parachutes are used. Now the parachute also is one of the big technology. They are about 25-meter diameter, 3 parachutes, and to deploy them in an entangled free condition, we need the pilot parachutes. So there are set of parachutes which will be deployed at different altitude before we finally touch down. So uh, 50. Now this is the slide which talks about the how the crew escape will happen in the different conditions. We can have the anomaly at pad. We will follow the mode 1 of abort. We can have the anomaly at when we have ejected the service crew escape system. Then we will use the service module itself as a means of crew escape, and they can come back. Uh, a little bit more on the atmospheric re-entry. This slide elaborates a little bit more about how we protect our uh, module by installing the tiles of a different categories. So the forward side is having a different technology, middle side is having a different technology, and the upper side has different technologies. And all these things are designed to survive the temperature of 1500 degrees C to 3005 degrees C. And you can see the re-entry velocity could be 28,000 kilometer per hour to 45,000 kilometer per hour, depending you are coming from moon or coming from the low Earth orbit. So these are the kind of velocity you have to handle. Slightly more some pictures of the parachute, which this is the actually care mission picture which was taken from the helicopter, which was chasing this particular module when it was in the terminal phase. You can see the on the left side, the first you have to remove the cover, so that has to be done through another parachute. Then you see this parachute and the pilot parachutes pulling out the main parachutes. So then main parachutes they are getting deployed. So these are very critical technology. Some uh, 25 highly time synchronized events have to take place to have this entangled free deployment of the main parachute. Then the communication system, because the crew module is not always visible from the India, it is orbiting the orbital module is orbiting the Earth every 90 minutes. It becomes very important to maintain the 24/7 crew contact. So there are two modes. There are a set of ground stations which are used to get connectivity, and also we have a plan to deploy the satellites in the geostationary orbit. You must have somebody would have given lecture on that, and that satellite is always tracking this particular the orbital vehicle, and there is always 24/7 crew contact available. Now, you also need certain set of communication system and the means to locate so that your recovery ships or recovery plane, rescue team can reach uh, for the recovery with the minimum latency. So there are satellite-based system as well as some visual flash beacon which keep on flashing, and you can see it from the 5 kilometer or even beyond, and zero down to the crew module as soon as possible. Then these are the pictures of how the safe recovery has to be done. So in fact, there is a flotation system on the top of this. Generally, if this particular system is not there, there is a probability that crew module can get flipped because of the high waves. And in that case, the exit of the astronauts will become a very challenging aspect. So we have designed the system where after touchdown, the parachutes will be cut, and there will there will be a float which will come up on the top, and then recovery ship will be positioned close to the this point, The Navy divers will go close to that, attach this particular ring to the module, and pull it close to the ship. And there are very specific crane which will lift the module on the ship deck, and then the astronauts will be taken out. But after taking out, they have to be isolated for some duration, and their health is kept under observation. In fact, their muscle is very weak, bone has also degenerated. So, depending on the duration of human space flight, the duration of quarantine or rehab varies. So, for the ISS mission, when the astronauts come down, it may be uh, maybe a 2 weeks to 3 weeks long, or even it can be a 45 days. But our Subhanshu Shukla, when he comes back from the space of a journey of 14 days, it will be about a week long process to bring them back to the stage that they can face the gravity again. Then, other than the engineering aspects, there are certain human centric aspect of human space flight. One of this is training. So, the astronaut selection and training is a very involved process. There are physical and psychological tests. Then the measurement of your ability to reach, that is called anthropometry, your body measurement. All these things are done. And for the initial missions, generally Air Force pilots, they are the best fit because they are trained to handle the high acceleration of the uh, they can survive high acceleration, and they are physically and psychologically very fit. So they have to be trained for the microgravity. So these trainings are done underwater, which is called neutral buoyancy chamber, and parabolic flight, where the few seconds of zero G conditions are simulated in the aeroplane, which is making the parabola while it is flying. Food, then personal hygiene, like space toilet. That is also one of the. So they have to be trained to use food in the microgravity condition. They have to be trained to maintain the hygiene in the microgravity condition. So it is. Sorry, just take some water. All right. So everything is well documented. Again and again, many time rehearsals are done before they are allowed or certified for space flight. The they are equipped with the survival kit, which consists of space medicine, then post survival, certain food, water, and other things. The space suit, that is also a very important thing. The space suit itself is a life support system. So they can survive in vacuum for a small duration. I mean, maybe some 8 hours without having any exterior consumables. So the space suit is, they have their own oxygen supply and its own communication system, which is directly connected to the crew module. And then firefighting system also is installed inside the cabin. So all these things are done uh, as a part of training, that they should be able to handle everything properly. And that is why the astronaut training is generally 1 to 2 year long before they are certified for the space flight. Now, pathway to our Gaganyaan. Uh, so everybody will be thinking that all these technologies exist. The rocket is there. It's all engineering. But the one of the difference between the normal mission and this, as I stressed earlier, is the safety. So the safety has to be, so you should prove it by test. So we have the series of test missions, which is called test vehicle mission. We do the airdrop test. We take the module at the certain height and drop it and test all the parachutes. We do the crew escape system test in the different mode. And then we are going to do the unmanned, uncrewed flight this year, which will be the full complement of the Gaganyaan configuration. Then two more uncrewed flight will happen before we actually launch the our first crewed Gaganyaan mission somewhere by the end of 2026 or early 2027. Now, just I would like to tell that from the Gaganyaan, we are going to migrate towards the building our own space station, which is a 5 module configuration. So 3 inline modules and two orthogonal modules. And this Bharatiya Space Station is going to be the test bed for lot of research, as well as our preparedness towards moon. So just a little bit of this is about for altogether 5 module will weigh 52 ton, and the 3 to 4 crew we can accommodate for short duration, uh, and 3 to 4 for long duration and 6 for short duration. The orbit will be similar to International Space Station, about 400 to 450 kilometer with 51.5-degree inclination. That means this orbit is chosen, which is quite safe from the space debris point of view. So there is a less probability of collision with the space debris. So we have the base module, core module, science module, lab module, and the common berthing mechanism. So as you see that we are putting a lot of emphasis to convert it into a orbiting laboratory and offer it as a platform to all the researchers. And this particular so the Bharatiya Space Station offers certain long duration microgravity opportunity. It offers the long duration exposure to space. It gives very unique perspective of planet, and you can do a lot of observation from there, and also a unique perspective of outer space. So you can do some astronomy and astrophysics kind of observations from there. So this particular platform is going to act as a laboratory which all the scientists, Indian scientists, science community can utilize and available. So now the question always comes that this can we can do all the experiments we can do in the remote mode, robotically, but certain biological experiments they really need the crew intervention. So the availability of crew on board enhances the ability to conduct the experiments and make observations to great extent. So the uh, space platform definitely enhances the means you can do the complex experiment in the less time. So there are opportunities to conduct the experiment in the several domain, which is physical science, biological science, space agriculture, astrophysics. Is in space manufacturing. There is a very unique thing like uh, there are certain things when you try to manufacture on Earth, the presence of gravity and sometimes presence of convection. These two things deteriorate, like the semiconductor crystal formation, certain optical component. People are doing the bioprinting in space, trying to print the mimic the retina, which cannot be done on ground. Pharmaceutical research that also uh, the the absence of gravity helps in uh, doing some very uh, controlled experiments where certain drugs can be discovered. The second thing, now the space radiation, the platform is available for the radiation exposure. So there are many things you can send the sample, expose it to the external radiation environment, and then accelerate certain things and experiment certain drugs. So pharmaceutical research is one of the very big area of the human space flight, and the its spin-off is going to help us a lot. And human research, there's the psychology and the physical and all those aspects. So anyway, this I can skip. Apart from this, the space tourism is coming up. So all these things are going to add. So now maybe I will end with one small video. I think I have time to 5 more minutes now. Hello, just so this is a this is our SRE experiment. The crew module is now Gaganyaan. How it is going to happen? Pad abort. The screw escape system getting tested. All the motors firing. And you see the parachute deployed. Now test vehicle mission. Testing the crew escape system in the high dynamic condition. Now building up the human rated launch vehicle. Stages are getting integrated. Astronauts will enter about T minus 3 hours. They will go through all the checks. They will feel lot of high acceleration up to 4G. Crew escape system getting ejected. Orbital injection of the orbital module. Solar panel will get deployed. It will start generating the power. Will orbit the Earth in a 400 by 400 kilometer orbit. Mission control will be always connected. Then deboost phase, service module gets separated. Crew module enters the atmosphere. The parachute deployment takes place. Flashes down. Recovery team approaches the module. All right. So I'm done with my presentation.